Okay, we're here looking at a follow-on video about solving equations in two variables, specifically simultaneous equations. We had a basics that we went through. Now we're just moving on to more difficult problems. So the basic idea here is that you want to be able to follow the steps that you use in the basic examples. Okay, so the elimination or the substitution method. With some of these examples that I have here, there are kind of things that you have to do first, preliminary or pre steps that you have to do before you can do the other steps. Okay, so when you look at, you have to kind of take it on a case by case basis. There are in this state 4 steps. Some problems you'll use all 4. Some problems you'll only use 2. Some problems you just go straight to the last step, just depending on the situations. But you look at them and say, okay, what do I have? And you work off that. So the first step of 4, you always try and sort out any fractions or decimals that you see. Okay, so because they tend to just increase the likelihood of you making an error. So it's best to kind of get everything in whole number format. Okay, you do that by multiplying every term by the lowest common denominator. All right, and we're going to go through examples down below, but we'll just go through the steps first. Second thing is decide which method to use. Okay, the two methods that we have, algebraic methods that we have at the minute, are substitution and elimination. So deciding which one of those to use. We'll go through how you decide that. Then we have rearrange equations so that each variable is in the same place. A lot of times equations are jumbled up. They're not exactly as you need them to be so that you can sort them out properly. And we're just going to again walk you through some examples of that. And then once you have all those done, in most cases then it's just a case of following the normal basic procedure as we did in the previous tutorial and solving that equation. So the first one, so we just have a list of a few different examples and we'll go through them quite quickly. Getting rid of fractions and decimals. The first one we have there, 3u plus 2v equals minus 21. 2u plus v equals minus 7. There are no fractions or decimals, so we don't have to, this step is not relevant here. The second one is the same, third one is the same, no issues at all. The fourth one down here, we see a half x plus 2 thirds y equals 6, 1/8 x plus 5/4 y equals 8. Clearly there are fractions there. Okay, so what we do is we basically we treat each line separately. So you look at the first line and says what's the lowest common denominator of 2 and 3? That is 6. So you multiply every term by 6, and we can see across on the right hand side here, we multiply 6 by half x plus 6 by 2 thirds y equals 6 by 6. And that simplifies to be 3x plus 4y equals 3b. The second line, again, separately, what is the lowest common denominator of 4 and 8? The lowest common denominator is 8. So you multiply every term by 8. 8 by 1/8 x plus 8 by 5/4y equals 8 by 8. So that simplifies down to 1x plus 10y equals 64. Okay, so we've eliminated the fractions from that system. Then we have the last one where on the second line you can see we have decimals. All right, and in this situation here, the simplest, most straightforward thing to do is to multiply by 10. Okay, because 0.2 by 10 is 2, 0.8 by 10 is 8. So you just multiply the second, just the second line we're interested in, multiply that by 10. Okay, then we come along to step number 2. Which method are we using? So the main thing is, when do you use the substitution method? You use this method when one of the variables has a coefficient of x. That is the number that is attached to the variable, the number right in front of it. If there are none of the variables that has a 1 in front of it, then you should use the elimination method. Okay, so again we look down, we're going to look down through all of our examples and see. So we have 3u plus 2v equals minus 21. This is the same example as we had before. On the second line you see we have v on its own, which is basically a 1v. So yes, that is suitable for the substitution method. The second one, no, because it's 2x, 3y, 3x 7y, or minus 3 and minus 7. So no, there are none there, so it's not suitable for substitution. So you do elimination for that. Third is the same. The next one, we scrubbed out the original one because we had changed them by we did the lowest common denominator thing in the example above, so that the new one is 3x plus 4y equals 3b, 1x plus 10y equals 64. And if you look at that new equations that we created, you can see that there is a 1x in the bottom, the second line, so yes, that is suitable for substitution. Go on to the next one, and again, there was decimals in the original second line here. We multiplied across by 10, and we looked at, we have 2x plus y equals 3 on the first line, so yes, we do have a 1y on the first line, so yes, that's suitable for substitution. Then we move on to the third step. The third step is to rearrange the terms to line them up. Okay, so what we mean here is if the u's and the v's and the constants aren't in the same place. So you can see from the very first example here, the u's are first, then come the v's, then there's an equals, then there's constants. So there's no rearranging needed in that first example. Okay, so we don't have to do anything. The second line, you can see the x's are fine, then we have the y's. On the first line we have the constant and then the equals, and on the second line we have the equals and then the constant. So they're not lined up. Okay, while the 9 and the 8 look like they're above each other, the equal signs need to be in the same place in both cases. Okay, so we just decide here that the constant 9 is on the first line, is on the left hand side of the equal sign. On the second line, the 8 is on the right hand side. So basically we've decided we're going to move the 9 to the right hand side, and you do that by subtracting 9 from both sides. Okay, so just on the first line we're subtracting 9 on both sides. So if we look over to the right hand side where it says under complete action, we've gone from 2x minus 3y plus 9 equals 0 to 2x minus 3y equals minus 9. So that's that sorted. On the next one, again in this situation we have the x's, then an equals, then y, then a constant, and then it's completely different on the second line. So the x terms are not on the same side, and the same for the y terms. They're not on the same side of the equal sign. And that's the focus. It's all about what side of the equal sign they're on. So we have to do two things. We have to move the 4y to the left hand side on the first line, and we have to move the minus 2x on the second line to the left hand side. Okay, so the steps to the right, so under complete action, you can see they're the two separate actions that we're carrying out. Okay, so the first line, it ends up being 3x minus 4y equals 14. Second line turns out to be 2x plus 3y equals 2. On the next example, no, nothing needs to change there, so we're okay there. Then in the last one, second line, yes, the x terms are not on the same side. So again, we're down here, 2x plus y equals 3. So we need to move the 2x on the second line over to the left hand side, and so that's what happens there on the very last box there. We are moving the 2x by subtracting 2x from both sides. Okay, and it's important to have the x's first and the y's next, and then the constants, same as the first line. We're just trying to match them up. So then we basically look and say, okay, this is just a summary of what all the changes we've made. So nothing happened the very first problem. It's exactly the same as it was at the very start. The method that we decided, if we look back up the screen, the method that we decided to use is substitution. So there's a gap over here to where it says solve the equation. So I'm not expecting to fill them in here, but it'd be a great idea now for you to finish these off using the method that has been decided. So the very first one here, 3u plus 2v equals minus 21, 2u plus v equals minus 7. Use the substitution method to solve that for x and y. The second one, we rearranged it because it wasn't all lined up, and we decided that was going to be an elimination method. So 2x minus 3y equals minus 9, 3x minus 7y equals 8. Use the elimination method to solve that. The third one, again, elimination. We had to do a little bit of rearranging of that one as well. Use the elimination method. The fourth one, 3x plus 4y equals 3b, 1x plus 10y equals 64. We're using substitution there. So we're just going to write in the numbers here. And then we have 2x plus y equals 3, minus 2x plus 10y equals 8, and we're able to use substitution there. Okay, so, and again, if you're not sure of the methods, just go back and watch the previous tutorial about how to use the substitution method, how to use the elimination method. Okay, so lastly, I'm just going to work through an example from the start. Okay, and we're just going to have a look and see what steps we need to do. So again, we have two lines here. We can see there's a fraction on the second in the second equation. They're not on separate lines here, but we can sort it out. So this one here, you can see we have fractions. So again, if you look back up at your steps, the first step was basically to eliminate fractions or decimals. So the lowest common denominator of 2 and 4 is 4. So we're going to just take the second line and multiply everything by 4. So we have 4 times x over 2 plus 4 times y plus 8 over 4 equals 4 times 2. Okay, we just simplify that out then. So 2 divides into 4 twice, so that gives us 2x. 4 divides into 4 once, so you can write it out as 1y, 1 bracket y plus 8 equals 8. Alright, the reason why I put the 1 there, and you're saying, sure, that's a waste of time, it's just y plus 8. But for example, if that plus wasn't a plus, it was a minus, well, then that minus 1 would be very significant because that would multiply into y and 8 and change both sides. So for now, we're happy that that plus 1 by y is plus y, plus 1 by 8 is plus 8, equals 8. Okay, so again, before we kind of start trying to eliminate or substitute anything, we just want to make sure we have everything tidied up. So we have, you can see we have like terms here. We have an 8 on the left hand side and an 8 on the right hand side. And because we've got the exact same thing on both sides, we can just eliminate them straight away. Now, if you don't believe me, what you can do is say, okay, I want to get rid of the 8. If I subtract 8 from both sides, we end up with 2x plus y equals 0. Okay, so we're taking that equation and we're going to put it in then with the 3x plus 2y plus 1. 3x plus 2y plus 1 equals 0. 3x plus 2y plus 1 equals 0. So this is our first line. This is our second line now, that the way we have them sorted here. All right. So again, we say, well, what method do we use here? The method that we use substitution if one of the coefficients is 1. And we can see here we have the 2x plus 1y or 2x plus y. So the first line, so the method we're going to use is substitution. Okay, so how we use substitution is we get one of the variables, whatever variable is on its own. In this case, the y is on its own. There's only one of them. We're going to get that on its own. How do we do that? Well, we eliminate whatever else is on that side. So we eliminate the 2x by subtracting 2x from both sides. So we end up with y equals minus 2x. If you can remember now with the substitution method, we take this minus 2x and we sub in minus 2x for y in the second line. Okay, so we go back up and say, okay, what was our second line? Our second line was 3x plus 2y plus 1 equals 0. All right, we're going to take minus 2x and put it in there instead of y. 3x plus 2 times minus 2x, so out goes the y and in goes the minus 2x, plus 1 equals 0. Okay, so we end up with 3x minus 4x plus 1 equals 0. 3x, and again we have like terms there, 3x minus 4x is minus 1x plus 1 equals 0. We want to get x in its own, so we're going to subtract 1 from both sides. So we end up with minus 1x equals minus 1. Then we still need to get x in its own. So we're going to divide both sides by -1. So we end up with x equals 1. Not finished. We just need to make sure that we find out what y is. So the simplest one to go back to is the very first one, 2x plus y equals 0. 2x plus y equals 0. 2x plus y equals 0. 2 times 1 plus y equals 0. 2 plus y equals 0. So again, we need to get y on its own. So we're going to subtract 2 from both sides. And we end up with y equals -2. Okay, so we have x equals 1, y equals -2. X equals 1, y equals -2. Now the question is, how do we know we're right? Well, what we can do is, we can now go verify our answers. So if you go back to the very original one, all the way back here, 3x plus 2y plus 1 equals 0. And 3x plus 2y plus 1 equals 0. 3x plus 2y plus 1 equals 0. If it works, these two values fit into both equations. Okay, so we're just going to sub them both in and see, do they fit in? Do they make this equation work? So we have 3 minus 4 plus 1. Does that equal to 0? Minus 1 plus 1 equals 0. Yes, so it fits into the first one. And we're going to go back and take the original one, x over 2. X over 2 plus y plus 8 over 4 equals 2. So we're going to just drop it in there and sub it into that one as well. Okay, so we have x over 2 plus y plus 8 over 4 equals 2. So what we said, x was 1 and y is -2. X is 1 and y is -2. And again, we are just querying, does this fit into both lines that we were given at the very start? Because whatever two numbers we've found must fit into both, because what we're finding is a point of intersection between two lines. So we end up with a half plus -2 plus 8 is 6 over 4. Does that equal to 2? Well, if we want to make them both into the same fractions, denominators, yes, a half plus 1.5 or 3 over 2 is equal to 2. Okay, so we have verified that our answer, which is way back up here, x equals 1, y equals -2, is correct. And we have verified that it fits back into both equations that we started off with. And that's a really important part of the whole process. Okay, and this is how to solve slightly more challenging problems.